said 30 on 567. Okay, I have the book. It's all already open in the background. Here it is. Okay, 567. Okay, so let's take a look at problem 30. This one. Okay, find the 4 second order partial derivatives. So we have f of x comma y equals x to the 5th y to the 4th plus x to the 3rd y squared. Okay, so first we have to find fx. When I differentiate, I get 5x to the 4th y to the 4th plus 3x squared y squared. Is this okay so far?
Yes.
Okay, and fy will be 4x to the 5th y to the 3rd plus 2x to the 3rd y. Now we want to find fxx. Fxx is 20 x to the 3rd y to the 4th plus 6x y squared. Fyy is 12 x to the 5th y squared plus 2x to the 3rd. Now fxy is 20 x to the 4th y to the 3rd and 6x squared y. Fyx has to be identical. Let's see. Fyx. So 20 indeed, x to the 4th y to the 3rd, and indeed plus 6x squared y. Good. Good. Next question. Anything else? Anything else we want to look at?
Can we go over question 14?
For some reason, I couldn't hear you. Can you say it again?
Can we go over question 14 on 5?
Ariana, can you write it in the chat? I think you said 14, but I couldn't understand. Is it the same page?
I think it was 583, she said. I'm not sure.
Is that
Yes, I did say that. 583.
and that's 14? Did I hear that correctly?
Yes.
Okay, perfect, perfect. Good. So let's go there. You said 583. Good. And we want problem 14. I'm assuming it's here. Okay. So we have very few data, 70, 60, and 85, 75, 62, and 89. Find the regression line. Y deviations are okay, and so on. The midterm score for a student, use the regression line to predict. So let me just read my problem one more time. Okay, good. So we go to the graphing calculator. And we go to stats. We edit, clear everything you had. And we enter 70, 60, and 85. And then we have 75, 62, and 89. Okay, so the first one is between, let's say 50 and 100. So I go to the viewing window, minimum 50, 100, with a scale of 20. I just want to see the scatter plot. and y minimum, let's say 50, and y maximum 100 with a scale of 20. So let me see if I have anything I want to clear here. Okay, good, pretty nice, good. Now I go to stats and I do calculations and I choose 4. Yes, yes, and I want variables and I want in the first variable, no. Okay, y variables, function, y1, yes, and I'll calculate. So I got the linear regression line, which is normally denoted by y hat as 1.068x, and then minus 1.237. Good. So now they're asking us to evaluate for 81. Good. Second in table, 81. Okay. So we got 85.3. So when x equals 81%, y hat, the predicted value, is 85.31. Any questions? Any questions on that? Good. Is there anything else that we have to go back and look at? Anything else? Other questions? Okay, so let's take a look at this list. So what we already looked at this moment is linear regression. And we looked at partial derivatives. So far, this is what we looked at. What would you like to continue with?
Can we do some work on substitution?
Yes, of course. Of course. Yes, so let's choose substitution. And let me share my screen. Okay, here it is. And the page I'm going, I have it open on chapter 4. Okay, I'm just looking for the page number, 434. Good. Anything you want to look at? Definite and indefinite, anything from 1 through 62. And beyond, actually, 66.
We do number 9.
Yes, let's work on number 9. So this is substitution. Good. Let's continue with number 9. Let me copy it. Number 9. Yes. The indefinite integral from natural log x to the 7th power divided by x dx. Of course, x must be greater than 0. Perfect. Good. So let's look at this function. This is the function, the integral from the indefinite integral from this function dx. Let's look at the function and come up with an idea. Any idea? Any idea? Let u be
N of x.
very good. Because du is very good. What is du equal to?
Would that be 1 over x?
du, not the derivative of the function, but du, the differential of the function.
dx.
Very good. 1x dx. So here it is. Here's du, and this is our u to the 7th power. So then the integral becomes u to the 7th du, which is u to the 8th over 8 plus a constant c. Since it's an indefinite, we have to go back to the original variable. It is a must. Good. Let's see if we need anything else. Any questions on this problem? Anything? See if you feel like working on anything else, or we move on to another topic.
Can we do number 4, please?
Which one?
Number 4?
Number 4. Good. Let's take a look at number 4. In number 4, we have the integral from x to the 3rd plus 1 to the 4th power x squared dx. Perfect. Any suggestions? We need a u, and the du. Any ideas?
U be x cubed plus 1.
Yes. Very good. What will the du equal to?
Three x dx.
You mean x squared dx. Correct. Yes. So we don't have that 3. Oh, who cares? We can make it up. We can multiply by 3 and divide by 3. If it's only a number and only a factor, we can handle that. So then we have a 1/3 in front. 3x squared dx is du. And what we have here is u to the 4th. So 1/3 u to the 5th over 5 plus a constant c. We rewrite this as 1 over 15. And we have to go back because it's an indefinite integral. X to the 3rd plus 1 to the 5th power plus a constant c. Very good. Any questions? Okay, see if we need another. If not, we'll look at another topic. So far we only chose indefinite. We may want to choose an indefinite, a definite. So all these are indefinite. Maybe you want to choose a definite, or maybe later. It's up to you.
We try 42.
Yes, let's try 42. 42. Yes, I see it. Perfect. Sorry, a sip of water. Yep, 42. And we have the integral from 12x, the 5th root of 1 plus 6x squared dx. Good? Good. So anyone can give us a u and then a du.
Is u 1 plus 6x squared?
Of course, this is the problem. Yes. So then can anyone give us a du now?
Would it be 12x dx?
Excellent. So the integral from, this is u to 1/5 du. 12x dx is this product, and the 5th root of u is u to 1/5. So this is u to 1/5 plus 1, which is 6/5 over 6/5 plus a constant c. I have to flip 5/6. I have to change u into 1 plus 6x squared to 6/5 plus a constant c. Any questions? Is this okay, everyone? Okay, let's go back. Anything else?
Can we do 60?
Yes, of course. Let's do 60. I highly recommend also look at the ones that we had in class when we discussed the topic for more practice. So we said 60. The definite integral from 0 to 2 from 3x squared dx, everything divided by 1 plus x to the third, everything to the 5th power. Okay. Any ideas? No ideas? Yes?
Is u 1 plus x to the third,
Of course.
and then du is 3x squared dx? I mean,
In-
yeah.
Indeed, right here. So that's the du, and the denominator is u to the 5th. Do not copy the limits of integration. Do not change the definite integral into an indefinite integral, please, if you want points on this problem. Now we have to change the limits of integration, and we do not go back. When x is 0, u is 1. When x is 2, 8 plus 1 is 9. So we continue. U to negative 5. So u to negative 4 over negative 4 from 1 to 9. Simplify it in the following way. 1 over u to the 4th from 1 to 9. Leave the constant outside. Change u to negative 4 into 1 to over u to the 4th. And then negative 1/4 again stays outside. 1 over 9 and when I to the 4th power. And when I plug in 1, I just get minus 1. I'm fine if you leave it as is. 9 to the 4th power is 6561. So negative 1/4, 1 over 6561 minus 1. You can leave it as is. I'm fine with this. Good. Good. So then go back. Where is my book? Here it is. Is there anything else about substitution that we need to review? Or we move on to the next topic? Okay. In that case, we can always go back. If not today, on Tuesday, if you find anything else. Okay. So we looked at substitution, we looked at partial derivatives, an example here, and we looked at the linear regression. Anything else? I'd like to touch up on all topics, and then again on Tuesday. What we should continue with?
Can we work on approximating integrals?
Yes. Yes, approximating integrals. Very good. So that was section, I think it was in 4.2. 4.2 or 4.3. Yes, it was in 4.2. Okay, so let me open, and the page is 402. Okay. Approximate the area under a graph. Approximate the area under the graph. All these. I will not ask more than 4 subintervals. Not 5, not 6, not 10, no, 4. 4 subintervals. So we may be given, so for example, let's say, I'm just going to copy any function. Let's say 21. So f of x equals 0.01 x to the 4th minus 1.44 x squared plus 60, and the interval is 2, 10, and of course 4 subintervals. So let's assume that this is, it can be anything. Let's say it's a marginal cost. We can call it c prime of x, or we can call it f of x, it doesn't matter. So let's say this is the marginal cost. And let's say the problem is asking us approximate the total cost using this interval with 4 subintervals. How will I approximate? I will just write this. I will not calculate the integral, where I'm not asked to calculate the integral. I will say the total cost, which can be total profit, can be total revenue, doesn't matter. I chose cost. The total cost is with 4 subintervals. So between 2 and 10, 10 minus 2 is 8. 8 divided by 4 is 2. So this is the first subinterval. Here's the second subinterval. Here's the third subinterval, and this is the fourth. So I have 1, 2, 3, 4 subintervals. Now let's suppose you choose. Do you want to use the leftmost point or the rightmost point? It doesn't matter. The idea is the same. But I want you to choose. You tell me what you would like to use. You would like to approximate